get started. My name is Jim Young, and I work in the Esri San Francisco office. Today I want to talk about where we've been, where we are today, and where we're going with web and mobile mapping. But first I wanted to watch a video just to set a little context around that.
Start with a story idea. Sell the story to management. Think, how do I create this story? Need data, lots of data, more data, big data. Where do I find the data? Call each department. Collect the data. Not enough good data. Survey new data. Call the lead GIS expert. Build a crazy model. Another model. No, not that type of model. Bring in an analyst to analyze the crazy model. Don't have a good base map. Call in the cartographer. Build a base map. Not ready yet. Go back to management and ask for more budget, more time. Be told you have no time and no budget. Work nights, work weekends, take a course in GIS. Output map, put in folder, mail to client. New rules. Start with a story idea. Grab data from the cloud. Choose template base map. Add photo from your phone. Share with departments. Tweet client link to map story. Clock out early. Every map has a story. Tell yours.
So if every map tells a story, what's the story that this map is telling here? This is the second most used app on the iPhone. We all use it every day, those of us that have iPhones, and yet it's not really telling any kind of story. Wouldn't it be far more useful and far more interesting to see where my friends have eaten and get recommendations? Or maybe to see when I walk into a high crime neighborhood and kind of personalize that experience, or even just show something like where my next meeting is. I think we're really missing a big opportunity to personalize that map experience and to really kind of contextualize that information for people on their phones and through the mobile web and through mobile native applications as well. But before we kind of look out too far to where things are going, I think we need to look back. This image here is, of course, looking back at Earth from Apollo. And there's a scientific concept called the overview effect. It's been reported by many astronauts, and it refers to the experience of seeing firsthand the reality of the Earth suspended in space. And the astronaut's brain is literally rewired after he or she experiences that being away from planet Earth and looking back on it and seeing our planet in that context. And even many people here on Earth that received and saw that image when it was sent back from Apollo 17 reported a similar kind of change in awareness and change in perspective. So if any of you guys haven't seen this image before, I apologize because you're permanently changed now. But kind of maps in many ways do the same kind of thing. They give us this sense of place and they give us a sense of context about our surroundings. And we've been using maps for centuries. We use them to explore, we use them to navigate, we use them to tell us what is near, and we use them to put a layer of understanding on the world around us. But even before computers came along, we've been doing some pretty sophisticated things with geography. This is actually the original Google Street View. In the early 20th century, you could actually buy turn-by-turn photos with this kind of paper-based guidance system. And there was actually a device, this like kind of contraption thing that clicked onto your steering wheel. And as you navigated, you could have your passenger, hopefully, again, back to like texting in cars and things like that. You could have your passenger basically look up the referenced photo in this kind of street level, street view kind of application. But things obviously got really interesting once computers became a tool for geography. We became able to do things like layer information on top of other information. And our local governments and our enterprises were able to kind of start to have this universal view across systems and across infrastructure. And geographic map layers could then kind of be, across these different systems could be normalized against this idea of a map. And it really resonated with a lot of people, this kind of human capability to consume these pretty complex pieces of information. Using the map as a metaphor is something that people relate to, and it's the reason we're all sitting in the room. And then the whole internet thing happened. consumer mapping entered into our culture. And with things like MapQuest, we actually, remember back to printing our driving directions, going online, typing in a start point and an end point, pressing print, taking it in your car, and that was great. And it was very basic. We look back on that and think of it as somewhat basic in the sense that you could click to the right or to the left an adjacent map, and the whole page would refresh. And you could zoom out, and the whole page would refresh. It was very useful for us, but still, at the time, the experience was a little clunky. And then consumer mapping really went mainstream when Google introduced what we in the GIS world call the Slippy map, and it was really a game changer. This single browser window that didn't require a page refresh when you zoom out, when you pan, when you scroll, and the page acts more like an application. And it stores the tiles up on the server at various zoom levels and kind of anticipates your next move and pre-caches some of that stuff. So it creates this much smoother, richer experience. And so with the rise of this consumer mapping stuff, the idea of these mashups then took hold, where web developers could take simple point data and place that on a hosted base map as pushpins. And it was easy to take these sets of point data, like Chinese restaurants with addresses or maybe some crime data, and just kind of place that up on a map as point data. You could take an address, geocode it pretty easily, get an XY back, and then pop it up on the map. And maps then kind of became this first-class citizen of the web. But as we're entering into this world of big data with massive complex data sets, the pushpin metaphor doesn't scale up to these larger volumes. How is mapping relevant to 450 million tweets that pass across the Twitter stream every day, or 1 billion cell phones in use with these location things? And that big data is very powerful. We're able to see a lot of insights into patterns that can lead to decisions, but we need new ways of consuming these massive data sets. And so what we want to do in this session is explore where it's kind of starting to go. And that kind of leads me to this point. Up until now, we've all thought of GIS as this totally separate field of science and field of study. And to a large degree, once you look at the application stack and above that, it is. There's a lot of nuance to what we do. But as we start going down this road, it becomes, we're tackling the same problems that computer scientists tackle. We're dealing with scalability, we're dealing with usability, we're dealing with these big, robust Hadoop unstructured data feeds, and how do we process that geographically? And if you think about it, what percentage of the world's information that has location associated with it is actually in a spatial index or in a spatially enabled database? It's actually not a lot. I don't have numbers to support this, but intuitively we know it's not a lot. There's tons of CSVs out there. There are tons of relational databases that have address information or unstructured databases. And there's a huge opportunity to visualize and analyze a lot of these other large data sets. And so this is kind of how we view the location stack as we include mobile into this conversation. This is how we envision the location stack and the location ecosystem today. Each of these buckets represents a ton of various companies, of startups, large enterprise companies, and the whole gamut. And it all delivers, the value is really getting delivered to the enterprise user and to the consumer up at that app services level. That's where we're going into the iTunes store, we're grabbing our application, and we're walking around and using it. But sitting on top of that app, in many cases, is this whole stack of stuff that sits under that other companies are powering. You've got these kind of geo-focused platforms like Apple and Google, and on the more enterprise-focused side, like Esri. And what all of these platforms are doing is providing these geographic building blocks to make it easier for those app developers to kind of bake or insert geo into their applications without having to understand all of those complexities underneath. And then below that, you've got data. You've got open data. You've got proprietary or commercial data sets that are kind of powering a lot of these decision tools and a lot of these frameworks. And then on the mobile side, you've got all sorts of positioning technologies. So everything from GPS when you're outside to Wi-Fi, which is useful to augment that. It's also very useful for indoor location, to trilateration of cell phone towers, which can also kind of speed up a fix as you land in another country or another city. The reason we're able to get those GPS fixes so fast is because it's also checking to see Wi-Fi and cell networks that are nearby to speed that up. And even things like sensor networks, where you're taking a fixed position on a loading dock, and as your products or as your inventory passes through that, it's getting geocoded with those sensors. So that's kind of what things look like today. Where are we going though? What's next for web mapping? And how are we moving past this metaphor of simple push pins into analytics? And I think this next generation of mapping and location is all about context. It's all about data and analytics, powering context and powering this, taking your data and interpreting it and building a story around it. And many of the apps that we use every day now as consumers and also as enterprises revolve around this concept location. And all of the data exhaust coming off of those apps is ripe for analysis. Things like Uber and Foursquare and even Salesforce and Evernote. It seems like most new social and mobile-focused apps for both consumer and for enterprise have that location as a vector to what they're doing. And all of this data can benefit from spatial analysis. So what do I mean when I say analysis? I want to be clear on the difference between just placing dots onto a map and asking questions about your data, asking questions about what's stored in your data. This is just an example of an analysis which says, I'm here, where can I get in 3 minutes via driving? So that's a very different visualization than taking some data and geocoding it and putting it on a map. Even things like which of my sales territories have the most competitors in them, and start to ask questions and get presented back visualizations of answers. Things like elevation services and elevation models. So San Francisco looks really different on a 2D map than it does once you start adding in a Z-axis. I like to ride my bike. Imagine writing a little app that could take that elevation model into place where you could then find the flattest path from downtown to Richmond or something like that, where you can then say, I don't like pedaling up hills. Downhill's great, but give me a simple path. And again, it comes back to this idea of asking questions of your data. And I want to show something that kind of answers a little bit about where we think it's going. I'm going to hop out of the presentation and try to pull up demo. Of course, the screen's too big. Let's try that. And now I'm driving on that screen, so we'll see what happens. So this is a map. Let me zoom out a little bit. This is a map we built for in partnership with the city of San Francisco, and it's kind of looping through. So let's just let it sit for a second. It'll start over. If you look down at the bottom, there's a little counter of 12 years of data. So we took 12 years of data around commercial permits and residential permits. That shows our goal was to tell a story of urban growth, broken out by neighborhoods. So as it's growing, you can see the kind of translucent areas that are on the outer circles. Those are residential permits that were issued. And the inner circle are commercial permits. And so you can see like the financial district up in the top right really growing in terms of business. and Soma growing, obviously in kind of the late 2000s, growing with residential growth as well. And one of the things we tried to do was add context to this data set as well. So we took a bunch of other variables, like some demographic data sets, and added those into the top right, so you can kind of click around on different neighborhoods, and it'll bounce around between neighborhoods and tell you a little bit about who's living there, so you can learn a little bit more kind of relevance to the data you're seeing. And then also down at the bottom, year by year, as it passes along, there was some survey data that the cities had about these different neighborhoods, and you can see how they felt about transportations or parks and things like that, and whether it was increasing, just as index kind of data, but whether it's increasing or decreasing. So I want to pop back to presentation and talk a little bit more about data. Because again, remember back to that stack, data is a critical piece of powering ultimately these applications that we all love. And there are a variety of data sets. Obviously, open government data is hugely valuable to everybody in the room and to kind of the developers that we work with in San Francisco and in other cities. This idea of the government taking data and exposing it as raw data and letting people, whether it's federally at data.gov, municipal governments, state governments, all of that raw data that's getting exposed is so valuable once you start to mix it together. Other data sets that are really powerful, there's imagery, of course. Companies that we work with that are flying satellites and getting down to 30, 20, 10 centimeter accuracy, resolution, these very high resolution images that you can provide both as base map layers and start to process and ask questions of the actual imagery itself. And then there is the social data, which is extremely interesting and becoming a lot more important to a lot of the work that we do. Because what that does is census data happens every, I don't even know how many, every 7 years or whatever it is, but that's a snapshot in time. The social data is obviously a lot looser, and the quality of that data isn't as rich necessarily, but it's extremely fresh and it's extremely live in the sense that you can start to visualize what's the conversation that my constituents are having, or what's the conversation that people are talking about my brand in real time, presented geographically. And that allows you to gain a lot of insight into this kind of more near real-time GIS or more near real-time geography. Open source data is a very important point and a very important concept for us as a community. Things like OpenStreetMap, where we're all kind of collectively building this standard Wikipedia of maps that we can all start to leverage and contribute to and correct and add value to. Commercial data, we do a lot at Esri with purchasing and aggregating commercial data sets. So things like when you go in and search for a place name, we want to make sure those place names and those commercial place names are very accurate, very reliable, and updated. So all of that sort of data is really important. And then derivative data, and I think this is extremely interesting. So back to things like imagery, what can you learn from a raw satellite image that you could then sell it back into the marketplace? So there's companies, for instance, that are taking raw imagery and they're running algorithms to do like edge detection on the rooftops. So you can actually then pull out the individual buildings and look at the direction that the roof is facing, maybe the tree coverage and where it is kind of latitudinally, and actually calculate solar capacity across a city just by running algorithms against imagery data. And then you could sell that back into a marketplace as a solar capacity layer. And so this idea of taking data and creating derivative data products out of that and pushing that through some sort of marketplace, I think is very interesting. Indoor is another place where this is all going. So we're starting to get good at navigating and finding ourselves and understanding the context of what's around us outside. It's early days for indoor. Think about things like shopping centers or airports or campuses, university campuses and corporate campuses, stadiums, and finding your way, giving you the ability to find your way inside the same way you're finding your way outside right now. And in fact, taking you all the way maybe to your seat at a stadium rather than taking you to the building or the arena. I think back to like trying to find my classes in college. I would have loved to have been able to be routed right to Econ 101 rather than it's kind of over in this building that might have another name. Or finding a bathroom in a large shopping center. Like if you could just pull out your iPhone the same way you can find your way to the airport and just, where's the closest bathroom, and it could route you there. Or like in Vegas, getting out of a casino. They make that a big challenge, but imagine if you could just pull out an app and say, quickest route out of here. They might not like that. But my point is there are a lot of indoor location problems that are going to start to be solved in this market. 3D data is another big important area for this whole ecosystem. We as humans experience the world in 3D, so it's only natural for our maps to be modeled in 3 dimensions and presented in 3D. This is the Esri campus in Redlands, and we've built out some 3D models around that. But think about things like college campuses in New York or cities that are vertical, where your campus might exist across 4 buildings and disparate floors in that building. Like a 2D map just doesn't work at all for those kinds of use cases, and 3D really provides a lot more power into facilities management and all kinds of use cases that the GIS community is addressing. And then I want to kind of come back to this idea of social, because I think this is really, really interesting and really where things are going. I want to show a quick demo about social. I'm going to come back to, this one's going to be a little harder because I have to actually type in this other screen. I can't mirror it. So I'm going to refresh this so it's pulled down as new. Hopefully my Wi-Fi is fast. This is a project that we put together that actually is a disaster response initiative. I'm going to zoom into Manhattan a little bit and maybe kind of get down to street. Are we seeing kind of streets and stuff? And here, so this is, we took the entire volume of geo-tweeted data with one of our partners as Hurricane Sandy came into New York. It took 2 full days of very massive data set of Twitter data, and I'm gonna just filter it at, let's see, Sandy, power, and I'm going to just start streaming that data through a streaming engine. And what it's doing is it's taking the volume of Twitter data, millions and millions of tweets, and filtering against those 2 keywords, so tweets that contain the word Sandy and power, and processing them. And you can see down here the velocity of tweets per second that are passing through the system. So it's climbing, it's going to hit 100 tweets per second. You can see the total volume of matching Twitter data here, and then it's presenting it on a map. So you can start to see kind of and as you mouse over, you can see the actual Twitter data. But you can see people kind of migrating up to the north of the city, and you can see this visualization in real time of what's happening as a storm is coming into a major urban area and pulling power offline. And I think it creates a very powerful story. What it doesn't do, though, it doesn't give you a framework for, it makes a pretty map, but it doesn't give you a framework to make decisions. and to actually act on this data. So we took another stab at it. I'm just going to refresh the page completely. Let's see, hopefully it'll come back. Great. And we took a stab at I'll type in the same data at Sandy at Power. It's going to filter against those keywords. We took the same data, and now I'm going to lay down this grid of the same operational 200-meter grid that the city works with, that the city responder teams work with. And then what we're doing is using some math that I can't explain to you, but some statistical math to essentially, instead of just take the raw tweets as they come across, we want to actually statistically look for anomalies. So it kind of creates this normalized baseline pattern, and then color codes the ones that are statistical anomalies inside of those grid cells and begins to highlight those. And you can again see the same velocity. It's climbing up to 100 tweets a second as the storm's starting to hit. And inside of these color-coded cells, people are saying, things to do with Sandy and Power that are very dense and more explicit. And what starts to happen is areas of that grid cell begin to start to pulse because they've now been flagged potentially into like an alert system. And I'm not suggesting that this is going to replace anything, only that it's another data source that we can use to be real-time responsive to actual events as they're coming in, taking the social data stream. And so you start to see some grid cells that are active and potential problems. And so then you can kind of mouse over and get a little data about the conversation in a grid cell. And actually even there's one that has an image that you can then click on and come up, and boom, you can see the fact that the southern end of Manhattan's without power. This was an actual tweet that somebody just posted that was geocoded, and get some context there. So again, back to the stack, the platform that sits below the applications in this kind of geographic framework. We think of that geo platform as we look at the world in these four buckets of value, where you can deliver platform value to applications above it. And core mapping is one thing, so that's all of the things that we associate with putting tiles in my application, routing, geocoding, getting directions and search, place name search, and things like that. That's interesting and important, and that's kind of table stakes for playing in these worlds, in these app developer worlds. But then above that, we focus on enrichment, and again, this is the idea of contextualizing that data, contextualizing your data as you load it into a GIS or as you load it into a geographic system. You can put that data down as points, you can put that data down and aggregate it up, but if you have these other data sets out there to begin to tell a story about whether it's lifestyle data or spending data or census and demographic data that's very granular, you can begin to complement your own data and contextualize it into a map that people can use as a decision platform. And then down in the bottom left, analysis. This comes back to this idea of asking questions about your data, where you're able to then perhaps put a few layers together and run some geoprocessing against that to do sales territory analysis, or to begin to start to ask spatial questions that can be answered and use it as more of a decision tool than just a visualization tool. And then finally, and this is why we're all here today, is mostly to talk about mobile. And this is what I'm most excited about, which is the ability to begin to make all of that data that's stored in our GIS systems and in our business intelligence systems and all of these different back-end systems. There's a ton of data in those systems that represents huge amounts of value to constituents and to customers. And if we can then bridge that to mobile and bridge that to people's location, we can start to make that turn that data from a noun into a verb and start to make it actionable. And we call this, one word we use for this is geotriggers. So the idea is that you can start to define boundaries and put fences around different things and essentially kind of wake up and make your mobile app actionable based on where it's located. And so this is really the idea. It's to take that geographic data in your back end and let your application do certain things based on where it's located, this idea of context. And really ask that question, what could your app do if it knew where it was? And so here I want us to think about this. When we think about GIS, when we think about location, when we think about geography, we always think about maps. And it doesn't necessarily, when you're building these mobile applications, a map may not necessarily be the best metaphor to consume that data. You can create other experiences that interact with geographic information stored in the back end that don't necessarily need maps. Maps can complement what you're doing, but so here is an example of kind of how this GeoTrigger framework works, where you can create events. It's almost like a rules engine that you can create events for when you arrive into a defined area. What does your application do? Or if you dwell for a certain amount of time in an area, what does your application do? Or if you leave a geofence, what does your application do? This kind of gives a sense for what that feels like and what that looks like. So as you're moving about an environment, again, these defined locations can trigger, your app can kind of trigger a push notification. But it can also do a lot more interesting things based on the data that you have resident in your back end. So crime data, statistical data, whatever. You can do things like, instead of just pushing notifications, you can do things like URL callbacks, where you can call into a separate hosted web service. Imagine walking by a Walgreens, and it can then kind of check in the back end. It can do a URL callback in the back end to say, does this guy have a prescription available? And if so, push out a notification, say, hey, pop in Walgreens and pick this up while you're here. So the idea of context as you're moving about. Or there's a bridge that's going to be under service or under construction. As I'm commuting, a couple days before, why not push out a notification that says, hey, we just want to let you know that there's going to be a construction project coming up in a couple days, because you might miss the little sign that just sits there and flashes on the highway. And so this is kind of how do we start to take a lot of this civic data and begin to power it with location. One of the ways we've been working with this is with the city to put little geofences around individual bus stops. So as you step into a zone like that, it can start just pushing the information about when the next bus is going to arrive. And then when you leave that area, hopefully you got on the bus or you got frustrated and walked away, but essentially it would stop. So you don't have to go in and click a bunch of things and do a bunch of stuff to get information. You're just kind of like moving, and it picks up your context and starts to tell you, what's happening. We're also doing things like with weather. There's some data sets out on the internet that are very interesting, real-time data sets that are very, very tight locations. So you can do things like walk outside and it'll tell you, boom, it's going to rain in 10 minutes based on your specific location. And thinking about those kinds of things as decision tools as well. So we're building these, again, back to the platform, we're building these geographic building blocks, geographic Legos for people to be able to put this stuff into their applications. We're not trying to kind of build consumer-facing applications. We're not trying to build specific enterprise applications. We're trying to enable people to take a lot of this complexity and just throw it in their applications and do something interesting with it in the market. Things like geocoding and place search, we want to make that super easy for you just to like plug that into your application. Things like routing and directions, so how to get from point A to point B, or even multi-point routing, how to get from point A to point C via point B. So I can use this thing to kind of dynamically create a route, and my application then just knows where to go based on my position. Things like all of the mapping and visualization type things that through JavaScript APIs and things like that, where you can build very complex, beautiful interfaces and then just call these geographic services, call feature, storage and query of feature services on the back end that are hosted, and then they're kind of baked into whatever front ends, whatever user interfaces you guys, or people are building. And so that's all I've got. Thank you.